Alright, nerds and nerdettes, this one's going to be pretty dry. In this episode, I'm going to go ahead and step through all of the programming necessary to get the startup sequence working, and on the video we'll show engine 3, so when it gets to its step, we can kind of watch the phases of the program execute as the engine goes through its startup sequence. So first things first, variables need to be determined and defined in the program. So we have an X, Y, Z, and a W. So first, X, that is going to be the default motor speed, if you will. Y, that is which motor we are working on. Z is going to be kind of a timer. So essentially it's just a timer that ticks up at a predefined step in the program. And same for W. And Y is important, but we'll get there as is needed. Then we have our actual motor control outputs. We need to define which pins that the Arduino uses for that output command. So we have, 9, 6, 5, and 3. That's because on the Arduino Nano those pins are the pulse width modulating pins. Otherwise, you would just get an on-off signal through the rest of the other pins instead of the rapid, pulse width modulation frequency that comes out that allows us to do speed controlling. Then really simply, we've got the pin mode definition, so the Arduino knows that those pins are outputs, not inputs, which is, that's pretty simple. And then I wanted a 5-second delay. So the Arduino runs in milliseconds on the timer. So 5,000 milliseconds is 5 seconds. And I wanted that delay because when I plug it in, the lights come on immediately, and I didn't want it to go lights on immediately startup sequence. I wanted a little bit of delay. So by putting that single delay in the setup phase, it executes once. It does not continue to execute between loops. So it doesn't interfere after that single execution. Now, moving into the actual loops. We start with the defined, the definition of which loop to execute. So running through engine 1 here, we're going to see y equals 1, which is which engine the Arduino is currently running the loop for. Then I want z is less than 10. Again, z is kind of a timer. So I just essentially want to say that, 10 is my cutoff on the z timer. Anything above that will execute something different. Anything below that, or below and above will execute something different, essentially. And I'll explain as we go along in the actual program. X is less than 150. So remember I said that X is our actual motor speed. And then W, I have that as another timer, is less than or equal to 6. So what you're going to see with W is that W is essentially the initial kick, because electric motors require, it's kind of like if you've ever seen one of those old school fans with the rotary knobs to turn them on and set the speed. You always see it like off 3, 2, 1, with 3 being the highest speed. The reason it's done that way is because electric motors need an initial higher pulse width kick or a higher voltage kick to actually get them turning and overcome that static friction on their bearings and on any internal seals or anything like that. So you need that higher voltage kick to get them started. Then you can cut the power very quickly to a lower setting and maintain the rotation, but if you don't have that initial kick, they won't rotate. If you don't believe me, feel free to go get an Arduino and a motor and set your pulse width to a low value and start, iterating it up and see where the motor starts turning. And then, set the value of where the motor starts turning and then drop it on the next timer, and you'll see that it does continue to rotate. It just goes very slow. So we need that initial kick on the propellers to get them to start rotating, because there is a little bit of rotational inertia there that we have to overcome. So on the initial kick, we're going to set the motor here. I've got 40 out of 255 for the initial kick pulse. And then you'll see the W equals W plus 1. So I want to essentially run that loop 6 times. And so each time it steps through, it's going to add 1 to the W value until W gets larger than 6. And then it'll move to the second step of the loop. And it's going to drop the motor pulse width to 30 out of 255. That's just, the 255 is just the ratio for the Arduino. That is the highest value it goes to. And that's just a native Arduino thing. I don't know if that's based on anything else, but for all intents and purposes that I need to know, I don't need to know what it is. I just need to know that the max value is 255. So anyway, we're dropping to 30, and that, reduces the pulse width to the engine, lets it rotate slower so that I'm not sitting at 40 the whole time, because there is a noticeable difference. And you also notice that in each loop, I'm going to have a 100 millisecond delay. That's just to not to start stacking up latencies in the Arduino. It just lets it rest a little bit, if you will, between executions. So we're going to iterate through the slower speed until W is equal to 50. Then we move down to the next loop. And in the next loop, we're actually getting into the business end. This is the actual, ignition/startup. So when we get to this loop, we're still in engine 1. Our Z timer is set at 10 now. We're not going to change it from there for the time being. Our speed's less than 150, so we're still accelerating. And the W timer is greater than 50, which is, the W is just the kind of the kick timer, so it's not going to change further from this point. So essentially we're just going to output engine speed. So again, we're only starting engine 1 at this point, so we set that, and that's going to pull in the predefined 100 number from the top of the program where we set it up, and then it's just going to start running it up. So it'll go on the next loop, it'll trigger that, or those conditions are right to trigger that loop again, so it'll go to 101 and then 102 all the way up to 100 and essentially 49, at which point it kicks over into the next loop, which is engine 1 fully stabilized, running at consistent speed. And so it's going to sit there, output X as 150, and that's going to be it. That's essentially the full running speed of that motor. We're not gonna slow that motor down from now on through the startup sequence. We're going to switch over. So we're defining Y is now equal to 2. Again, Y is the value that defines which motor we're currently starting. X, we're going to reset back to 100. And we've already executed the run portion, right? That motor 1 control has already executed, so it's putting out 150. Then we reset to X. Z, remember that's our startup timer, or one of our startup timers, and W is our other startup timer. Those we're going to reset to 1 so we can reinitiate a startup for engine 2. We're going to run a delay because I want some time between engine 1 getting to fully stable and then engine 2 starting. And then essentially we restart the whole process again. Now, I will point out that for W, you need to test this because motor behavior is different motor to motor, especially when you're buying the cheaper, just straight DC motors that aren't 100% like an actual hobby motor, right? So they're relatively inconsistent relative to each other. So you need to test them and see what values make them happy. And for my case, engine 2, it wanted 7 here to get to the correct speed. So I varied it. The other thing I will point out, that loop set to loop set, I am changing this last delay line because I don't want it to be a uniform time between each motor starting. Again, this is all pilot triggered, so I do want some variation there. It just makes it look a little bit cooler. Okay, so as we watch engine 3 run this sequence now, initially we've got our higher voltage kick, or a higher pulse width kick. Then we immediately slow down to the lower voltage, and you'll see this is a 33 now. Again, that's what made that motor happy. So we've got that lower pulse width sustainment of the quote-unquote ignition, the cranking portion of it. Then we move into the ignition phase, where we see a rapid acceleration of the motor, and then we stabilize up to full speed. We stabilize here for a little while, and then we go and start engine 4 sequence. So, real simple. Again, this code's all available in a Reddit post that I put up on my Reddit page. Feel free to download it, run it, execute it. As long as you've got your Arduino wired consistent to the way this is programmed and the way mine is programmed, it'll work. It doesn't just work on the every. You'll just need to watch your pinouts to make sure it works if you're using like, you know, a regular Arduino Uno or whatever the bigger one is, Mega. You can essentially run it off of any board. Just you got to watch your pinouts. All right. Thanks for watching. I hope this helps. And as I said, I knew it was going to be dry, but if it helps someone, perfect. If it helped you, like, subscribe, and tell me that it helped you. I'm curious to see your project. Have a great day, guys.